Good morning, everyone. Welcome to the technical session 8C. My name is Siddhi Auti and I'll be your moderator for today's session. On the behalf of Global Knowledge Research Foundation and GR Scholastics LP, it is my great pleasure to welcome you all to the 9th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2025. The ninth edition of the conference is being held organized in a hybrid mode. The physical event was held yesterday in Pune, and the virtual event was held yesterday and today via Zoom meeting on 30th and 31st January. I hope you will enjoy this knowledgeable and interactive session throughout the day. In this session, we are having in total 10 presentations, and each presenter will be given a time span of 10 minutes. After 7 minutes, I will be raising a gentle reminder. 2 minutes are kept for question and answers. There is also another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or updates, you can write it to me in the chat box and our team will be solving those. Now, just before we get started, I would like to introduce you all to the chair for this session, Dr. Bimal Patel.
Good morning, ma'am.
Good morning, sir. Dr. Bimal Patel is an associate professor at Charosat University, Gujarat, India. He has guided more than 5 students at master level and published more than 23 papers in reputed journals and international conferences. His research interests include large language models, green IoT, MANET, wireless sensor networks, Internet of Things, and denial of service attacks. Welcome, sir.
Thank you, ma'am.
Now we'll start with our first presenters. So the very first participant we have here today is Nisarg Dubaria from Charotar University of Science and Technology. And the paper title is A Comparative Analysis of Intrusion Detection System Models, Suitability of Datasets for Smart Grid Communication. I request Nisarg sir, if you're there in the meeting or anyone, any of the co-authors, to please start with your presentation.
Yes, ma'am, sure. Ma'am, my screen is visible.
Can you try to reshare it?
Okay.
Now it is visible.
Okay, so hello everyone. My name is Nisarg Dobaria from Charosat University. I'm a third year BTech student. The paper title was a comparative analysis on intrusion detection system models and suitability for dataset for smart grid communication. My paper number is for 461. My co-author is Rutik Dobari, Sarita Thumar, and Rikita Choksi. So let's ahead. One second. So this is the content of discussion of today's presentation. So first of all, introduction. Smart grids are a modernized power system that integrates digital
You
technology.
can skip introduction. That's fine.
Okay, sure, sir. So here is the cybersecurity threats and the role of intrusion detection system. Smart grids vulnerability. Smart grids are vulnerable to various cyber attacks, including denial of service, data manipulation, and unauthorized access. The role of IDS. The, the major role of intrusion detection system are crucial for identifying and responding to malicious activities within the smart grid networks. The main problem statements. Main problem statement, despite advancement, smart grid remains susceptible to cyber attacks. Existing IDS models face challenges in accurately detecting threats in smart grid environment due to dataset limitations and evolving attacks technique. Therefore, optimized IDS solutions are needed. um, I, IDS models are classified into three categories. Specification-based IDS detects deviation from predefined rules. Misuse-based IDS identifies known attacks patterns. Anomaly-based IDS uses AI/ML to detect unusual behavior. A key challenge is selecting appropriate dataset to train and evaluate IDS model effectively. Comparative analysis of IDS model. IDS models are primarily built using machine learning, decision tree, random forest, and SVMs. Deep learning, CNN, RNN for more advanced pattern recognition. And third one is hybrid model, a combination of ML and DL to enhance accuracy. Each approach has strength and weakness in terms of detection accuracy, adaptability, and computational costs. Dataset used in research, dataset used in IDS research. Uh, there are many commonly used datasets like NSL, UNSD, then UNSW, IDC, IDS, and many more. There are model performance like which IDS uses which model. So the random forest is approximately using 30%, and likewise. So evaluating performance metrics and benchmarking, detection accuracy, identifying attacks correctly, false positive rate, avoiding misclassification, and scalability, handling large smart grid data, response time, speed of threat detection. Models like federated learning and CNN GRU hybrid shows promising results. Now we talk about the challenges. The challenges in IDS for smart grids, limited real-world testing, lack of real-world smart grid dataset, scalability issue. IDS model must handle large data volume efficiently, balancing accuracy and privacy. IDS should detect threats while maintaining data confidentiality. This is the chart of how much can IDS growth in smart grids year-wise. Uh, Future enhancement to improve IDS effectively. Future research should focus on deploying smart grid specific dataset, deploying real-world IDS implementation for validation, exploring edge computing for real-time threat detection, optimizing MLDL model for better scalability. So let's head to the conclusion. IDS is essential for protecting smart grids. ML-based IDS model offers strong potential for accurate threat detection. Future research must focus on real-world dataset and practicing uh, practical implementation to enhance IDS efficiency. So here are the references of the research papers, and thank you.
Thank you, sir, for your presentation. Are there any questions from session chair?
Yes, yes. So the thing I want to ask is probably it's kind of survey for IDS for smart grid, right?
Yes.
So you're not perform anything right now.
No. We have studied and compare more than 16 to 17 papers for.
Okay, but At the end, you should get conclusion that whether you are going for a machine learning or whether you are going for a hybrid model to solve the disadvantage of smart grid or not.
So, solving the problem of this, we can mm, go to the hybrid models
But
because
then you need to conclude based on research paper as well as the result. So Nisa, you can note down this point and probably as a future work, you can continue with the help of your mentors.
yeah, sure, sir.
Fine? Okay, thank you.
Okay.
Anyone else would like to ask a question, they can continue. Else, it's done from my side. Thank you.
Proceed to the next presenter.
Okay, thank you.
So the next paper title is a comprehensive survey on AI-based systems for detecting package damage and food packet spillage. And this paper will be presented
What,
by Tinu AV from Raj Lakshmi Engineering
what
College.
did you?
Hmm? Hello. I
Good
request
morning.
Tinu ma'am if okay. Ma'am, can you please start with your presentation?
Yeah, ma'am, sure. Okay. Good morning, everyone. I'm Tinu. I'm going to present this paper on a comprehensive survey on AI-based systems to detect the package damage and food package spillage.
Ma'am, your screen is not visible. Yeah, fine. Okay.
Is this visible, sir?
You can continue.
Yeah, thank you. So, in today's world, we could see that online ordering and delivering have been rapidly increased. So, which raised the need for to maintain the package integrity and also to maintain the food packet without spillage. So, this ensures that efficiency and also the food safety. So to when we look into the traditional method of checking the packages and also the food package, we use the human labor, which may prone to human error. So to to address this challenge, we have done a project on developing a CNN model. So, which automatically detects the food package with spill and also the food package with spill and the package with damage. So it is also designed with which triggers an alarm or some sounds when the system automatically detects the damage in the package or any spills in the food package. So following this, so these are the problem statements we are focusing on. Yeah. So, ensuring that food packaging remains intact is important for keeping the product safe and at high quality. So, if packaging gets damaged, it can lead to spoiled products, financial losses, unhappy customers, and even health risk. So, traditional methods for checking packaging issues like spills or defects are often slow and prone to mistake, especially with fast production lines. So, to solve this problem, we need a system that uses the machine learning and computer vision to quickly and accurately detect any packaging issues in real time. So, making the process more reliable, we are using the convolution neural network model here. And these are some of the research papers we have surveyed. So the first one is the is identifying the cracks and misalignments on the packaging industries and beverages. So which uses the deep learning based image techniques. And second paper is these also a pre-trained model is used here to detect the damages like bruising, cuts, and discoloration on the potatoes. And third paper we have seen is the detecting the damage on the steel surfaces which also uses the deep learning models. And when we are looking to the fourth, it is identifying the defects on the yogurt cups, like the package seal improper seal were identified in here. And when we look into the fifth paper, so it is identifying the defects in the agriculture products and the adulteration. Here, AI driven methods were used. And the sixth is the identifying the cracks in the materials like concrete and metal. So here, CNN model is used. And when we look into the seventh paper, similar to sixth, your CNN model is used to detect the car damage, and also its severity of damages identified here. And at the eighth paper, the scratches and dents were identified using same CNN based network. So when we see these papers, we could see that deep learning models and AI models were familiar and were used more on these papers. So in conclusion, we decided to use the CNN model, which is used to predict the complex patterns on the images, and predict the accurate and give the accurate result. So we have decided to use the CNN model. And so these are the objectives of our project. So here, deep learning model to develop a deep learning model is one of the objective. And we have set a trigger to alarm, so real time alerts were integrated with the final module. And the accuracy and the speed. So when we think of a assembly line, checking the products on the assembly line to detect the model with a complete accuracy, to detect the object with the complete accuracy is one of the thing of concern. So the model should match with the speed of the assembly line. So we ensure that our model is fully accurate and speed. So the proposed system is, here we have decided to use the CNN model. And finally, we have integrated the model with the Django, which is a website. So the website where the real-time images were uploaded, and the result will be given in back to the screen. So here, if the damage is detected or any spill is detected, the alarm is triggered, and it makes the sound. So the employee around there could check for that and remove the product which is damaged or spilled. So this is the system design. Here, image acquisition. So here the database were collected in image acquisition process, and the data labeling. So here we have decided to keep the model with a 4 classification, like the boxes with damage and without damage, and the packets with spillage and without spillage. So after data labeling, data augmentation process will be done. And after that, the data will be splitted into training and testing data. So once the model is tested, the model is deployed, and the alert mechanism were connected to it. So this is the flow diagram of a project, and which is similar to system. So here, yeah. So the methodology focuses on 4 modules. Here, the first module is the manual architecture, and second is the AlexNet architecture, and third is the LayNet, and finally the interface development is on the fourth module. So in manual architecture, we have decided to use certain layers, which helps us to know how the layers work and how layers matches with the accuracy and the speed of our objectives. So here, convolution to the max pooling, flatten and dense layers were initially used on the manual architecture. And so this is the flow of the module 1. So raw image were done, and a sequential model with these layers were built. And after that, the model is trained, and it is tested with the testing data set. And the second module is the AlexNet architecture. So the reason we are using these models like the manual architecture, AlexNet, and LayNet are to compare the accuracy the model gives. So
Madam,
at
can you
last,
show can you show some result? Actually, I got the idea what you are trying to present.
Yeah, okay, so till now we have implemented the module 1 and module 2. So like the accuracy is like in the first module it is like 65% and the second module is near to 95%. So the reason we are checking or training these three models is to get the model with the highest accuracy and integrate it with the final interface. So at the second module AlexNet, we get the 95% accuracy. So and after checking the LANet architecture, we could come to the conclusion that which model is best to use at the interface, you integrate with the interface, final interface. Yes. And the reason we have used the AlexNet module is that it is the one module that introduces the non-linearity. So non-linearity helps the model to uh, a model to capture the complex pattern from the images, and it is efficient to use that model to detect the images accurately. The damages were identified, and also the splits were identified efficiently
Ma'am,
in the AlexNet.
ma'am, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yes, ma'am. So, in conclusion, model focuses on the accuracy and the speed. So, by comparing the models, we could select the model with greater accuracy and integrate with the final interface. And if you look into the future development of this model, it could integrate it with an automated harm like thing. So, which automatically splits the image, split the products with damage and without damage. If the so instead of alert system which calls for an employee to take the damaged product, it can be integrated with an automated harm like thing. So it splits the damaged product from the assembly line and uh, make the transit a smoother one. Thank you.
All right, ma'am. It's really a good idea. Congratulations for your work.
Thank you, sir.
Few questions which are in my mind is in your one of the model you are getting 68%, and then one of the other model you are getting directly 95%. So
Yeah,
why
yes, sir.
somewhat the vast difference between these two?
So the basic reason is that the layers used. So in the first manual architecture, we used only the four basic layers. But rather, if we look into the AlexNet architecture, where the loop of the layers were used. The more layers, the number of layers used is a large difference between the from when we compare it to the manual architecture. So we can
Fine.
see that max pooling, convolution tree. These are the
Okay.
layers. Yeah.
So in your architecture slide, you have shown something like you are taking a pictures and then you are trying to pass it to a model and so on.
Yes, sir.
So what sort of, instead of that, probably you can consider something like a data site of Zomato or Swiggy from a previous few years, and then probably you can continue with a live model also. It can be done as a future work.
Yeah, yes, sir. But when we look into the food packet spillage detection, a particular product can be chosen there, like in production of something like lace or some packet items. So if we
Hmm.
take a particular product, we can take the
Hmm.
product and we can collect the images of different types of damages it could get. Like the damage may be due to the conveyor belt, or it may stick on some of the nail, sharp needle. So the damage could be of different types. So by collecting the different types of damages of the particular product, we could get the
Hmm.
final good product, like without a spillage and without any damage. So when focusing on a particular product, I think this is necessary. So
Fine. Thank you. Thank you. It's really a good work.
thank you so much, sir.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter.
Thank you.
So the next paper title is Behavior-Based Driven Drowsiness Detection Using Convolutional Neural Network, CNN. And this paper will be presented by Smita Mahajan from Symbiosis International Deemed University, India. I request Seema ma'am to start with your presentation. Smita ma'am.
Yes, thank you, ma'am. I'm sharing my screen. Please confirm if the screen is visible. Is my screen visible now?
Yes, ma'am.
Yeah. Very good morning to everyone. I'm Dr. Smita Mahajan from Symbiosis Institute of Technology. I will be presenting my work on behavior-based driver drowsiness detection using convolution neural networks, CNN. So, the content of my topic would be introduction to the topic, objectives of the study, relevance of my proposed work, statement or the problem, statement of problem or scope of the project, then any research gap or question that I might be coming across, and methodologies and tools used, results, conclusion, and references. So with your kind permission, I would like to start the discussions. Uh, so we all are very well aware about that. Driver, when they are driving on a longer routes, more than 40% of drivers admit that many a times during their journey on the highways, especially long routes, they have fallen asleep behind the wheels, and this is really a dangerous or kind of risky situation where because of the long driving the drivers are facing the fatigue, which leads to some major accidents. And it was estimated that 1,550 deaths, 71,000 injuries, and almost $12.5 billion monetary losses are due to drivers' drowsiness in some of the references that we have seen. So we are proposing a system wherein we can have the system implemented which detects the fatigue which drivers are facing, or looking at their behavior like bodily you can say actions or facial expressions, and then we can set an alarm. The system is intending to do so, so that we can awaken the drivers, and that can eventually stop the further losses that which would incur if otherwise driver falls or feels like sleepy kind of mode. So this is the basic motivation behind our this particular project. This project also can be utilized to drivers fatigue if they are feeling fatigue, not only sleepy but if they are tired, etc. Also, we can find out apply this particular project in drowsiness detection in case of industrial environments where the hazardous situations and workers are working for a longer hours. So the objective of our study is to develop a accurate system using ML-based object detection techniques and deep neural networks. We have to learn the features of facial region and detect the drowsiness, especially eyes we are focusing. Then continuously monitor drivers' facial features and present an alert if drowsiness signals are detected, and to explore the system use of the system for other domains like aviation, military, manufacturing, and healthcare. So, as I have told you that to address the critical problem of driver fatigue and drowsy driving, we have chosen the deep neural networks, that is CNN. And to improve the accuracy of our system, and the problem that we are trying to make, or the final problem statement that I would state as the driver fatigue, which is a major cause of the road accident. The goal of this particular study is to develop the drowsiness detection system using ML and neural networks as such. So going ahead, so currently there are a couple of systems which are already existing in the market, but their systems face some certain drawbacks, which I am mentioning over here. The very first thing is dependence on user behavior. Some systems require manual user involvement. Means the user himself or the driver himself is required to do some certain tasks, like pressing a button or performing some task, something like that. Which definitely, if a person is feeling sleepy, then such kind of activities can't be taken care by the driver itself or the person sitting nearby. Another challenge of the existing system is cost. The current existing systems are very expensive to implement, especially if they require the specialized hardware as well as the software. Now, privacy concerns also is one of the major problem, where the system may collect some sensitive data, for example, some biometric information, so which needs to be addressed, because if such kind of data is captured, that can be utilized somewhere else for other purposes. Also, false positive detection is also one of the challenges we have seen what other people have done. So generate too many false positive, and thus it reduces the accuracy, and thereby you are compromising the user's trust on your system. So a couple of systems are sensor driven systems. So once again, some dependence on another sensor, like they rely heavily on external sensors such as EEG sensors, like electroencephalogram sensors, or EMG sensors, which is electromyography sensors, and infrared sensors. So again, investment and working of these sensors and integrating these sensors with the system becomes one more overhead for the existing system, and that significantly increases the cost and complexity of the system. So to take care of this, what we have done is our system is better in the terms of it is non-invasive, so it does not require any user to wear or any sensor or any device as such. It increases the user's comfort and compliance. It obviously incurs lower cost compared to others. Only a camera and a computer are required, and it becomes more accessible and cost effective. What I'm calling camera, you can utilize a phone also, so normal mobile phone also you can use. Also, it gives you the real-time monitoring. So this system provides the monitoring of user's eye and can detect if the user's drowsiness is detected looking at the eye's status. So which may help to prevent the accidents or injuries as well. And this model can be customized, or algorithms can be modified as per the user's requirement. So that customizability also we have given. So the model that we have implemented, as I have told you, it was a CNN model wherein we have used the convolution layers, which are max pooling, 2D convolution network. Once again, means such kind of layering. Then the flattening the output, the layering part is required to extract the features, and then we are using this kind of architecture, the shown in the diagram. So the convolution neural network model is used to for image classification. What kind of image it is? Image, as in we are, as I said, we are mainly focusing on eye. So obviously, the classification of eye, whether they are feeling drowsy and no drowsy. So this was detected by taking the eye images, and the openness of the eye, how much they are open, how much they are closed. They have helped us to identify whether the person is eyes are drowsy or not drowsy. So convolution layers learn from such important features from the input image. Max pooling layers reduces the size of output from the convolution layers and reducing the computational complexity of the model. And dense layers are responsible for performing the classification task. So the training and validation was done where Keras was used for pre-processing and training and validation. So this helped and improved the robustness of the model. Model is trained using ADAM optimizer, which is adaptive learning rate optimization algorithm. Pre-processing was done by using image data generator, and we have given the lots of data. Also, the loss function used for the classification problem is categorical cross entropy we have used, which is commonly used for multi-class detection classification problems. And to improve the model's generalization ability, the training data is split into 80-20 kind of training test, and also 7 folds of validation. K equal to 7 was set for the validation test. The model's performance is evaluated on the validation set after each epoch to prevent the overfitting. And the technique used in this project is building the CNN model. The model's performance was evaluated using the evaluation. So overview of system can be given as capture the live stream and convert it into individual frames. Process the pre-process, that it detect eyes and send it to the model. Classify eyes as either open or closed, even semi-closed. So we have kept the percentage that overall vertical size of the eye, if it is more than 50%, the eyelid is covering the eye, then we are classifying it as it is the sleepy kind of nature. Then compute the drowsiness score and determine, to that we have given the score and determine if the person is drowsy or no drowsy. So the results which we have got is the which was including the alert section of this system responsible for alerting the driver when the drowsiness is detected. The alert is triggered when the system's driver's drowsiness is detected. Detection algorithm determines that the driver's eyes are closed for a certain period of time, because sometimes blinking can create some confusion. So in this fashion, we could achieve the accuracy 97.66%, and the validation loss was 17.80, and after 15 epochs, we could achieve the 94.23% of accuracy. So the proposed system presented is a novel and effective solution for identifying and alerting drivers in a real time when they show the signs of drowsiness. The system was developed using CNN, and as I said, we could achieve some good results. These are some few references that we have used. Thank you so much for patiently listening to me. I would be more than happy to take the questions. Shall I stop sharing or let the sharing be open? Thank you.
Fine, ma'am. You can stop. No issue.
Yeah.
Again, one more good idea, ma'am. So congratulations for your work.
Thank you, sir.
Actually, one of my friend who is probably at Symbiosis Pune, Dr. Shanil Pandya,
Yes,
is
yes,
right
sir.
now in Sweden.
Yes, yes, I
So
know
he's
him.
probably working in this area. A lot of things he
Yes,
has
sir.
worked on this part.
Yes, sir. Yes. Yes.
And second thing is, madam, nowadays probably we are getting a ADAS system as well as desk and camera already inbuilt in a system, which is trying to
Yes.
even find out the linking assist part also. So how this system probably will differ to other part?
Yes, sir. Definitely, I would say that CNN is that way nowadays, because in our AI/ML area, every 1 month down the line, something new comes up. So obviously, this particular system is definitely has the kind of little lack of integration. So, but future scope may we can definitely add the module which can integrate our system to the next level of or advanced version of the existing system. I have not yet tried that, sir, but I will definitely check how those systems are performing, and then accordingly I can try to update my system to bring it to that very level.
All right, ma'am. Thank you.
Yeah, thank you so much, sir.
Thank you, ma'am, for your presentation.
Yes, thank you so much. Can we leave, ma'am, because I have my next session there.
Ma'am, actually, it is expected from all the participants to stay till
Okay,
closing
I'll be
remarks.
connected. Yes, yes, I'll be
We have few
connected.
instructions to give. Okay.
Sure, sure. No worries.
Thank you, ma'am.
Yeah, thank you.
So the next paper title is Clustering Driven Insights for Recommending Ideal Student Locations. And this paper will be presented by Aswath Krishna, SD, from Coimbatore Institute of Technology, India. I request Aswath Krishna, sir, if you are there in the meeting, please proceed with your presentation.
Good morning, ma'am. I'm sharing my presentation.
Yes.
Please confirm that you
Yes,
get.
it is visible.
Yeah, thank you. So, good morning, everyone. So, myself, Ashwath Krishna, and my co-author, Dr. M. Suchitra, from the Department of Computing Data Science, Coimbatore Institute of Technology. I will be presenting our work on clustering-driven insights for recommending ideal student locations. Without further delay, let me move to the introduction part of this presentation. So, in the age of today's world of urbanization and rapid technological advancements, data-driven decisions have become essential. For students, one of the most fundamental choices they make daily is related to food. These choices go beyond just nutrition. They affect health, routines, concentration levels, and academic performance. Our main objective, our study aims to address this by identifying locations that align with students' food habits, ultimately enhancing their living and learning experience. Moving to the next slide, the clustering techniques. We have tested with 3 different clustering techniques in our research. Starting with K-means clustering. K-means clustering is widely used for its ability to group data into homogeneous clusters, minimizing intra-cluster variance. Second, hierarchical clustering. Hierarchical clustering is used for revealing nested structures in data and providing an intricate view of groupings. Third, DB-scan, density-based spatial clustering of application with noise, ideal for identifying dense clusters and handling outliers, offering a unique perspective on data. Each technique contributed uniquely to understanding the student data and location data. Foursquare API. To gather precise and location-specific data, we used the Foursquare API. This is a public API This API provides access to over 105 plus million places, locations, and supports retrieval of venue data and user interactions. It was pivotal in building our recommendation system by mapping location data to student preferences based on their preferences like food preferences and eating habits. Let me take you through our methodology. First, the data collection. So the food choices data captures key features such as cooking, eating out, and living on or off campus. A sample of the data have been displayed in the part of the presentation. And the second step is data pre-processing. The data was cleaned, normalized, and prepped for analysis. Third, we applied k-means clustering, hierarchical clustering, DB scan techniques to group students based on their food habits. Silhouette score. So silhouette score is a accuracy metric which determines the wellness of the points are clustered. Uh, it ranges from -1 to 1. The higher the number, the higher the wellness of the clusters. Through silhouette scores, k-means clustering proved to be with scored as 0.39% and hierarchical clustering with 0.34, DB scan with 0.25. The effectiveness and consistency of applied clustering techniques were validated. Continuing, the application of k-means clustering proved with 4 different student clusters based on living conditions and eating habits. So next, 4 location clusters are also determined, each catering to unique combinations of dining and grocery options. So using Folium package in Python, we plotted these clusters on a map, giving us a spatial representation of potential venues. Finally, our system recommends venues that matches a students cluster, providing personalized suggestions. Our recommendation system have been built to be detailed. The recommendation function is a Python function that remaps the alignment with the cluster numbers in both the students data and the location data, and mapping those cluster numbers between the student data and the locations data. Results. Using the elbow method, we determined 4 clusters were optimal for both student and food preference location data. Next thing, like the k-means clustering revealed distinct student groups based on or off-campus living and eating habits. Hierarchical clustering displayed data structure, while DB scan identified dense clusters and outliers. So again, the silhouette scores comparisons reaffirmed k-means as the most effective technique for this data set. The pictures of the data set after clustering by k-means clustering algorithm and hierarchical clustering is also displayed in this presentation. Results. Moving to the result section, here is a basic representation of the recommendation and the recommendation suggestion for a particular student. The developer recommendation system successfully matched student clusters with location clusters, ensuring suggestions aligned with their unique food preferences. For example, students preferring on-campus living and eating out were directed to clusters with nearby eateries, while those who preferred cooking were guided to clusters with grocery options. The different color points shown in the map are different clusters that were identified with the k-means algorithm. And the next picture in this slide shows the places recommending to a student based on their food preferences. Yes. The conclusion, we successfully mapped students' food preferences to real-world locations, offering actionable recommendations that could improve their quality of life. This research not only benefits students, but also provides valuable insights for institutions and for urban planners. So moving forward, the future, this research could also extend to system by incorporating larger data sets, feedback mechanisms, and adaptive recommendation models that address broader societal impacts of food choices. Thank you for your attention. I'm open to your questions.
All right. So can you tell me the size of data set you have considered and from your getting a data set?
Yes, sir. We have used 2 different data sets, as I mentioned. One is the students' data, and the other is the location data, which have been retrieved from the Foursquare API. The first data set, the students' data set, we have gathered it from the Kaggle global platform for data sets and machine learning related work.
So just my suggestion is probably you can try to think of considering a data set of single university, and then based on the confusion matrix data. Even you have not shown the confusion matrix data, whether the food preference you are getting is a correct one or not.
Yes, sir, I got it. Yeah, we can
Right?
like
So that you can add, it's
uh,
fine. The idea is good, but you can start from the smaller things and then you can jump to the higher data set or a bigger data set, and then you can continue with the part of clustering.
yeah, sure, sure. We will take this and we will do it in our future works.
Okay, thank you.
Thank you, sir. Thank you so much.
Thank you, sir, for your presentation. Now, the next paper title is Ethical Security and Privacy Considerations for Internet of Medical Things Adaptation for Developing Countries. And this paper will be presented by Ofalitse Fale from University of Botswana, Botswana. If any of the co-authors or the author is present, please start with your presentation. I think he has not joined. We'll proceed to the next presenter. So the next presenter is Priya Dhonda from Dwarkadas Jivan Lal Sanghvi College of Engineering, India. And the paper title is Intelligent Phishing Detection Using GNs. Priya ma'am, if you're there in the meeting, could you please start with your presentation?
Yes, of course. Just a second. Is my screen visible?
Yes.
Okay. Hello, good morning. I'm excited to present our work on intelligent phishing detection using generative adversarial networks. Our goal with this project was to develop a robust system to detect phishing attacks using advanced machine learning techniques. Uh, To give a quick introduction, phishing is one of the most common and harmful cyber attacks today. It involves tricking users into revealing sensitive information like passwords, credit card details, or bank information through fake emails, messages, etc. Despite efforts to combat phishing remains a significant threat due to the increasing sophistication of the attackers. Traditional methods like blacklist or whitelist or heuristic based systems often fail to keep up with these evolving tactics. This is where our project comes in. We propose using generative adversarial networks to create more advanced and adaptive phishing detection system. Our approach focuses on analyzing the URLs, which are often the first point of contact in any phishing attack. Um, so let's look at some of the existing work in the field. Previous research have shown that GANs can be effective in generating adversarial examples to test and to improve phishing detection system. For instance, the Robic Butz and Win paper demonstrated that GANs can enhance the accuracy of phishing detection models by generating synthetic phishing URLs. Similarly, this paper by Al Ahmadi introduced PG GAN, which is a framework that uses GANs to improve phishing detection by creating adversarial examples. PDGAN improves phishing URL detection by using adversarial process that exposes the discriminator to diverse URLs which are not included in the training data. Despite some URL details being unclear or incorrect, the PDGAN achieved extremely impressive results, outperforming other models without relying on third party sources. These findings highlight PDGAN's ability to effectively classify phishing URLs with high accuracy. Uh, just a second. For our data set, we have collected two main data sets, one containing 10,000 phishing URLs from FishTank and another with 16,000 legitimate URLs from web browsers. For each URL, we extracted 46 features such as the presence of IP addresses, URL length, use of special characters, and even domain related information. These features were encoded into numerical values, making them suitable for our models. The dataset was split into training, validation, testing, etc., to ensure the evaluation of the models. So our architecture consists of mainly two components, the generator and the discriminator. The generator creates synthetic phishing URLs while the discriminator tries to distinguish it from the real and the fake URLs. Both are neural networks. The generator is a feed forward network and the discriminator is a CNN with 6 convolutional layers and 3 fully connected layers. During training, the generator improves its ability to create realistic phishing URLs while the discriminator becomes better at detecting them. This sort of adversarial process ensures that a model stays ahead of evolving phishing techniques. So here we have the architecture of the generator. On the left side, it's a sequential model. It includes additional layers like batch normalization to stabilize the training. The generator takes random noise as its input and transforms it into synthetic phishing URLs. The output is reshaped to match the format expected to the discriminator. This design ensures that the generator can produce realistic URLs that challenge the discriminator. On the right side, you can see the structure of the discriminator, which is also a sequential model. It starts with a flattening layer to process the input, followed by dense layers to for the activation functions. The final layer outputs a single value indicating whether the URL is a phishing or a legitimate URL. The architecture allows the discriminator to effectively learn complex pattern in the data. Here we see an example output of the discriminator. The array shows scores that are assigned to different URLs. The scores that are closer to 1 indicate that it's a more legitimate URL, while scores closer to 0 suggest a phishing attempt. The output is used to classify the URLs in real time, providing users with immediate feedback on the safety of the websites that are being used. Finally, here is an application of our model in real world. We developed a browser plugin, the IPD phishing, which uses our GAN model to detect phishing websites in real time. When a user visits a website, the plugin usually analyzes the URL and provides a safety score. For example, here where you can see the score of 88%, the website is considered to be safe. However, if the score drops to, for example, 62%, the plugin warns the user that there might be a phishing attempt. This tool, I think, demonstrates the practical application of our research and its potential to protect people from phishing attacks. In conclusion, our GAN-based phishing detection system offers significant improvement over the traditional methods that are being used now. I think by using adversarial training, our model continuously keeps evolving to detect even the most sophisticated phishing attacks. This makes our system highly adaptive and effective to simple or even advanced threats of phishing. We believe this could have more benefits in the future. Finally, here are some references for some of the key references from our work and the studies that we referenced. Thank you.
Thank you, ma'am, for your presentation. Are there any questions or shall I proceed further?
I think consider larger data set as well as you need to show the confusion matrix data also. Because fine, you have taken 10,000 websites as a for a phishing part, but what about the accuracy part?
Yes, sir. So the accuracy was around 84%, which works well actually because the discriminator was not able to discriminate the data produced by the generator. So accuracy was decreasing, but it's better because the generator was producing very
So
similar
in that
and realistic phishing websites.
so in that case, you need to compare with the existing paper how they are getting accuracy and what is the main part that you are getting much more compared to other. Fine.
Yes, sir.
Okay. Thank you.
Thank you.
So the next paper is on Internet of Things in retail industry. And this paper will be presented by Amol Mashankar from Datta Mega Institute of Higher Education and Research. I request Amol sir to start with your presentation.
Yes, ma'am. Thank you. Just sharing my screen.
Yes.
I hope it is visible to all of you.
Yes.
Okay. So this is Amol Mashankar from DMIHR, that is the Atomic Institute of Higher Education and Research, Varda. And my topic for today's presentation is Internet of Things in retail industry. So as we know, day by day, the technological impact on the customers are increasing, and the sellers and the producers are getting advantage of this. So these are the different software, sensors, and other technologies that are used by the different retailers and the producers, and they are using to convert their uh, customers, those who are trying to visit to physically into the market, and they are trying to catch them their attentions in the with the help of these different technological tools. So it is basically has a customer focus. Retailers prioritize customers' experience and satisfaction, offering a wide range of goods and services directly to consumers for personal uphold consumption. Different omni-channel strategies are used by the retailers. They utilize brick and mortar stores, e-commerce platforms, and mobile apps, often blending online and store services to create the shopping experience of the customers. Now, there are different opportunities are related with the IoTs. That is, it is helpful for enhancing the customer experience. It enables personalized recommendations, interactive displays, and a self-checkout system, improving customer engagement and satisfaction. Second thing is it provides real-time inventory tracking, predictive analytics, and automated logistics streaming supply chain operations, and it helps to reduce the cost of the retailer to not to maintain that much quantity, and they can forecast their particular uh, stocks. And new revenue streams are also possible with the IoT. It opens opportunities for retailers to offer new services such as personalized shopping experience, data-driven insights, and connected product offerings. Here are some examples which are used by different companies like Amazon is there, Walmart is there, Tesco is there, Sofera is there. There are a number of companies, but I'm just taking few examples here. So they all are utilizing these particular things to create and to experience the good customers. Like Zora is a fashion retailer, for example. Sephora is working in cosmetics. So these are the some examples of companies that are using the IoTs. Few challenges are connected with this, which can be, if possible, maintained by the retailers, then it would be very helpful for them. The first challenge is cost. We know technology is not a static one, it is a dynamic one. It is changing day by day. It is getting advanced in very few days and months. So it is very important for the retailers to maintain these particular technological advancement. They need to spend some funds for this. It requires investment in hardware, software, and integration. Then second challenge is maintaining the privacy and security of their customers, because nowadays customers are getting very, there are different threats on the internet due to the stealing the data. They can be get affected negatively. So protecting sensitive customer data and ensuring compliance with the privacy regulations is very important. So that is again very important and very vital fact of this key. You need to maintain the data security of the customers. Third thing is system integration. Integrating IoT system with the existing infrastructure and business processes can be complex and require expertise. So you need that particular system to maintain this particular thing. As we look into the future, it has got immense importance for upcoming future in retail industry. So AI integration is a combination of IoT with artificial intelligence will enable even more personalized shopping experiences, predictive analytics, and automated decision making. Secondly, immense commerce. Augmented reality and virtual reality will create immensely shopping experiences, allowing customers to virtually try on clothes, explore products in 3D and internet with crucial assistance. Recently, I have seen a documentary. I'm not getting the name of that company, but now you can imagine your whole house in a 3D way, and accordingly you can design your house. So this is what the future of the IoT. Then blockchain technology will enhance data security, transparency, and credibility throughout the supply chain, improving the trust and efficiency of the customers. So finally, we can see that Internet of Things is transforming the retail industry, offering opportunities to enhance the customer experiences, optimize operations, and drive growth. While challenges exist, the potential of IoT to revolutionize retail is undeniable. As technology continues to evolve, the future of retail will be shaped by the innovative integration of IoT and AR and blockchain. So this is what from my side. Thank you.
Thank you, sir, for your presentation. Are there any questions?
I think probably it's a survey only, so probably I cannot even comment on that. But maybe, sir, you can include something like a proposed architecture combining
Yes,
various
yes,
trust
yes.
areas.
Yes, sir. Yes, sir. Thank you.
Because it will be difficult for me even to question also.
Yes, yes. Thank you.
So the next paper title is Rainfall Prediction Using Machine Learning. And this paper will be presented by Bakka Vamshi from Koneru Lakshmaya Educational Foundation, India.
Good morning, ma'am. Am I audible?
Morning. Yes, sir, you are audible. You can start with your presentation. I'll stop sharing my screen.
Yeah. Good morning, everyone. My name is V. Vamshi, and today I'm going to talk about our rainfall prediction using machine learning. This work was conducted by a team from Lakshmi Foundation in Hyderabad. Let's start with why this research is important. Rainfall prediction is not just about knowing whether to carry an umbrella. It's crucial for agriculture, disaster management, and urban planning. Traditional methods have struggled with the non-linear and dynamic nature of weather data. This is where machine learning comes in. ML can uncover hidden patterns in data to make predictions without relying on rigged rules. It offers a more effective approach for accurate rainfall forecasting. Now, let's talk about the challenges in rainfall prediction. Rainfall is influenced by multiple variables such as temperature, humidity, wind, and pressure. This complexity makes it difficult to predict accurately. Traditional statistical methods fail to capture the nonlinear patterns of weather patterns. This is why we need advanced, complex, high-dimensional data and adapt to changing conditions. Uh, let's move on to the machine learning models we used. First, we have the support vector machine, or we can finding the optimal hyperline that maximizes class separation. Next is a decision tree, which splits data recursively based on the best features to classify. We also used a random forest, which combines multiple decision trees to improve accuracy, reduce overfitting. We also used the LSTM, which captures long-term dependencies in sequential data, making it ideal for time series forecasting. Finally, we used LSTM plus CNN, both handle spatial and temporal dependencies. Let's move on to the machine learning models we used, and this is the functional block diagram. We started with data collection using historical data for our models. We then moved on to data pre-processing, where we handled missing values and normalized the data. Feature engineering was crucial, focusing on key features like temperature, pressure, wind speed, and humidity. We selected a and trained various models to find the best one. And finally, we evaluated the models based on their performance matrices. This is the data collection and pre-processing. Previously, I have told about it, and let's move on to the previous work which we have done by us. Before we dive into our results, let's take a moment to review some of the previous work in this area. Researchers have been exploring the use of machine learning for rainfall prediction for several years. For example, studies have shown that SVM and decision tree can be effective for short-term predictions, while more recent work has highlighted the potential of neural networks and ensemble models. Now, let's compare the performances of two of our models using confusion matrices. Uh, Here you can see the confusion matrices for the random forest and long short-term memory models. These matrices helps us understand the true positive, false positive, true negative, and false negative for each model. By these matrices, we can find accuracy, precision, recall, and F1 scores. As you can see, the long short-term memory model shows better performances in terms of correctly predicting rainfall events. Let's take a look at the performances of our models. We evaluated each model based on accuracy. The support vector machine achieved 77%, the decision tree achieved 71%, random forest achieved 85%, and LSTM achieved 85%. As you can see, LSTM provided the best performances due to its ability to capture long-term dependencies. We also explored a hybrid model combining CNN and LSTM, which provided the best accuracy. This hybrid approach combines spatial and temporal features, making it high effective. Faster processing enables a real-time weather updates, which is crucial for practical application. Overcoming computational and data limitations is key, and we believe further improvements can be made with IoT integrations. In conclusion, machine learning significantly boosts rainfall prediction traditional methods due to their ability to capture long-term dependencies. A CNN plus LSTM hybrid approach further improves forecasting by combining spatial and temporal features. Future work will focus on integrating IoT sensors for real-time weather updates, enhancing prediction, reliability, and responsiveness. Finally, I will like to acknowledge the work of other researchers in this field. Included a few key references here. Um, Thank you for your attention. I'm happy to answer any question you might have. Thank you, ma'am.
All right. So firstly, probably you need to consider the latest paper. I've seen your references. It is still from 19 and 20s, 2009.
Yes,
So probably you can get much more idea what sort of future work right now going on and so on.
yes, sir. We work on it, sir.
And second thing, as you rightly said in last second slide, is nowadays even in winter we are getting a rain.
Yeah, yes, sir. Yes.
So it's a bit difficult to predict the rainfall in that case. So you need to consider some sort of hybrid model for a future work.
Okay, sir. Definitely we'll work on it, sir.
Fine, thank you.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, ma'am.
So the next paper title is Real-Time Air Quality Monitoring and Predictive Pollution Control Using Big Data and IoT. This paper will be presented by Ebrar Khan from Mahatma Gandhi Institute of Technology, MGIT, India.
Hello, am I audible?
Yes, sir, you're audible.
I'm going to share my screen now. Can you please confirm if it's visible?
Yes, sure.
Is it
We can
visible?
see your screen. Yes.
Thank you. Uh, Good morning, everyone. I'm Mohammad Abrar Khan, presenting our research on real-time air quality monitoring and predictive pollution control using big data and IoT. This work, co-authored with Dr. Rajita Kotuju and Dr. Sugamya Katta, tackles a pressing environmental challenge using big data, IoT, and AI. So if you look at the motivation from where we wanted to tackle this problem, is because air pollution is a silent killer causing more than 7 million premature deaths per year, stated by the World Health Organization. That is equal to the population of the whole country of Libya. And yet, 70% of low income areas lack monitoring infrastructure. Why is that? Because traditional systems are centralized, and because of being centralized, they are very expensive and limited in coverage. So, without real time insights, the policymakers are too late to react to the situation, and people suffer. The goal with this research is to propose a low cost solution to monitor, to predict, and to reduce pollution in real time. So, when we look at the methodology overview, our system is mainly built on three pillars, which is IoT sensors and edge computing. And the second one is AI powered predictions using AI models and ML models. Third one is ensuring policy integration. So when we talk about IoT sensors, they are very low cost generally and they collect real time data. And edge computing is mainly used for faster processing and without the need of sending data without the need of sending data to a cloud server, we can transfer it to a local data server. And when we come to prediction models, we use the LSTM and GRU model. The GRU, which is mainly for to use historical data. It is used to predict air quality trends and it shows up to 95% accuracy when trained, enabling proactive decision making. And the AI insights also drive real world actions like dynamic traffic rerouting, industrial compliance, and urban green belt planning, which we look forward into. And then next is key innovations. The key innovations which you try to implement is the low cost sensors. The general sensors which are used for the centralized systems range from a range of $1,000 to $10,000, whereas these ones are 70% cheaper. And when trained efficiently, they can give results up to 90% accuracy. The edge computing is mostly solar powered. So in remote areas where there's no high-rise buildings, there can be a positive uptime of 95%. And then the hybrid AI models, we can use random forest and LSTM. So these decision trees can help collaborate with the LSTM model to prolong with the extended memory of the data. Next is the pollution pattern analysis. So the data analysis reveals key trends where traffic contributes to 25% of emissions. So when we use AI-driven rerouting system, it reduces idle time by 35%. And in winter peaks where many traffic vehicles may use heaters and whatnot, it shows 40% of pollution comes from industrial emissions. The system can flag high-risk areas for early intervention and then such that by analyzing pollution patterns, we can intervene when it matters the most. Next is results and accuracy. Although I'm not able to display the factual in this PPT because I was not aware of it, but it is when we train the LSTM and GRU model, it shows up to 90% accuracy with the help of using previous historical data. That is what LSTM is best used for with the help of ML calibration, obviously. And the cost reduction, as I said, it's 70% cheaper than conventional monitoring. The energy efficiency is also high due to being solar powered sensors, which maintain up to again 95% uptime. This ensures scalability and real world feasibility. So the predictive model which we are talking about, they are trained, they are trained AI to forecast pollution trends. LSTM achieved a better accuracy than GRU, again, for the same reason that it uses historical data. Uh, AI simulations also predict a 30% AQI improvement by 2030. So if these policies are implemented carefully, the air quality can improve by up to 30% by 2030 as predicted by AI. So this just proves that AI can not just monitor but also drive proactive pollution control. So next, this is a key factor when analyzing any research, which is the policy integration of how it fits into the community. So when we talk about urban planning, so the AI can help identify pollution hotspots and which can help the government create green belts and industry compliance. It can also help regulate enforcement where there's high activity of pollution and public health alerts as well. So we can talk about like forecasting pollution spikes and like giving a warning. So by bridging an AI and policy integration, the governance, we can move data to impact. So sustainability and scalability, this is important because when we talk about air pollution control, we need to sustain it in such a way that it provides us accurate results. So the system is being built for long-term sustainability by the help of remote calibration. IoT-based recalibration ensures longevity. And when we talk about scalability and sustainability, maintenance is the first thing which comes to our mind. So with just 15% expected annual maintenance cost, it makes it viable for low-income regions without the need of centralized systems. The conclusion and future work. So this is mainly a cost-effective process, 95% accuracy, and already helps in various ways theoretically. The future could be expanding to more than 50 plus villages, which could help envision us with more data and drone monitoring for wider coverage. Because clean air is a right and not a privilege. Thank you, and I'm here to answer any questions you may have.
Fine. Probably I need to share a recent scenario, something like you can consider the use case as a Delhi, where
Yes,
they are
sir.
having a lot of issue related to air quality, an issue, and then a recent experience is related to that our second ODI between India and England. Where
Yes, sir.
again
There
the
was.
fog plays an important role, and then there is a catch fight between the two nations.
Yes, sir.
Fine,
think
it's all probably I thought something like it's a bit theoretical. You need to refer a lot of papers and so on. And maybe you can think of something like an idea called nano robots. Or maybe you
Sure,
can
sir.
shift,
I'll look into it
or
and I'll.
maybe you can shift to a something like LoRaWAN as a sensor part.
Sure, sir. I'll look into it and I'll try to keep it up to date.
All right, fine. Thank you.
Thank you, sir.
Thank you, sir, for your presentation. So the last presenter of today's session is Nisha Verma from Dayalbagh Education Institute, Deemed University. I request Nisha ma'am to start with your presentation.
Sure, ma'am. Ma'am, I'm audible?
Yes.
Okay.
Now it is visible. You can start with your presentation.
Good morning, everyone. Myself, Nisha Verma, and my topic is the smart footwear, a survey report. Introduction. As literacy level, people are more increasing about their health. So about their health and appreciation. So basically, people are join gym and do practice outdoor activities regularly, physical exercises, do yoga, focus on dietary management, change lifestyle. If we will talk about dietary management, people are more taking proper fibers, carbs, protein from health and betterment. Physical fitness and variables. As we can see in market, many variables available like heart rate monitors for monitoring devices like heart rate monitors, blood pressure, oxygen level, sleep trackers, smart watches, smart rings, and smart footwear. Paradigm shift in footwear manufacturing, craftsmanship and mass production, foot customized footwear, mass customization, smart footwear, literature review. According to WHO, 422 million people have diabetes and 1.6 million deaths are directly attributed to diabetes every year. So a great risk of diabetes, which could be seventh leading cause of death by the worldwide 2030. Smart footwear. So we are focusing that parameters monitoring of health parameters like blood pressure, oxygen level, HP, temperature, and heartbeat and diabetic levels, activity tracking, environmental monitoring, battery life, and data synchronization, personal fit, and guidance. Design of smart insole and as well as smart shoe. Uh, se- Sensor IoTs, multiplexer, for data storage, AD converter, Bluetooth communication, microcontroller, preconditioning, data processing, and decision control. For all the block diagrams, we need power supply. Function block diagram of my smart footwear. Input and sensing and communication, data storage, data processing and information extraction, data analysis, decision making, control output. This is functional diagram of smart footwear. These are the components. You have many components based on the requirement, what type of smart footwear you want to develop. So basic component mentioned here. Start with sensors, microcontrollers, power supply model, user interface, integration module, software and apps, footwear material, storage module, and communication module. These are the different variables and sensors already available in market. Smart insole and research gaps. In smart shoe, the battery consumption is a major issue. Every component of smart shoe needs power. After fixed interval of time, we have changed the battery. And selection of optimal number of sensors is crucial factor to decide based on their working principle, type, weight, and size, which kind of sensor we need. So basically, we have to see क्या principle रहेगा, type, weight, and size, reliability and robustness. Smart footwear must withstand with environmental conditions like dust, dirt, water, humidity, temperature, various etc. हाई कॉस्ट स्मार्ट फुटवेयर बेसिकली जो मार्केट में शू अवेलेबल है वो हाई कॉस्ट है, तो आई वांट टू make my footwear like low cost. It will be helpful for normal peoples also. No research available in smart footwear which deals with physical and mental well-being. Objective of my project to design and develop self-power generating insole of footwear, identify the importance of feature and smart footwear, selection of by different sensor and their location on insole of smart footwear, design a suitable hardware and software architecture for smart footwear to develop a low-cost footwear for fitness applications. Methodology. In the beginning of the literature survey on the smart footwear, we will done by studying the national and international journal research and review paper. And after throughout literature review, the research gaps will be identified precisely and work upon these gaps. The suitable architecture is designed and implemented on the waste board and validate the functioning of smart features. Finally, design and develop the intelligent suit for fitness application. Workflow literature survey design and development of self-powered shoe, selection of different features, sensor IoTs of smart shoes, design and developing of hardware and software, design and developing smart footwear for fitness application. Conclusion, the development of low-cost smart footwear for fitness application highlight the potential of integration, machine intelligence, sensor and IoTs and wearables technologies. Challenges such as battery efficiency, sensor selection, durability, cost need, and address to make these devices more accessible and reliable. For role of smart footwear technology in the future contribution in a big way for well-being, physical and mental and spiritual. These are references. Thank you.
I think it's all survey, but still you need to study in detail the various types of sensors that you can apply for the smart footwear. Even you need to interconnect the orthopedic types of footwear that is available to check the result. Fine?
Okay, sure.
Thank you.
Okay, thank you so much, sir.
So we are done with all of the presentation. Now we'll proceed to the closing remarks. I sincerely thank our authors for their excellent presentations and contributions in this session. and all our participants for being a part of this international conference. I hope this session was informative enough. We on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of this conference. We will be more than happy to see you in the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I also want to thank our session chair, Dr. Bimal Patel, for chairing this session. A token of appreciation to the chair on the behalf of Team SmartCom 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence.
Thank you. Thank you so much.
Now, lastly, before ending this meeting, I request all of the participants to please turn on your cameras so that I can take a quick snapshot of today's session. We'll just wait for other participants to turn on their cameras.
Please grant the permission to turn on the camera, ma'am.
We have already given the permission.
Actually, the message is appearing like you cannot start your video because of the stop. Host has stopped it.
Okay, now
Okay,
you'll be
thank
able
you.
to.
Thank you. Yes, yes, thank you, ma'am.
Okay, thank you, everybody.
All right. Thank you all. Ma'am, can I leave? Because I had some other assignment.
Yes, sir, sure. We are ending the meeting now.
Thank you.